Welcome to part 3 of our live training session here with our GT500 Mustang. Now, the last tutorial we focused on startup and idle tuning. We got everything sorted out there so the engine is able to maintain and hold its own idle. And now we can move on to dialing in our part throttle driving and our wide open throttle type of a situation. So we're going to be focusing on dialing in our mass airflow curve, making sure that our airflow model is valid. Now we have everything dialed in so that we can move on to additional tasks such as dialing our spark timing in and the torque model in future training modules. Without further wait, let's jump in so we can check this out.
Welcome back to our live training session here with our GT500 Mustang. This tutorial we're going to be focusing on dialing in our mass airflow curve at both part throttle cruise conditions and wide open throttle. We have a lot of things to talk about here. Before we jump into doing the actual calibration process, I want to make sure you're up to speed of where we're at in terms of how we're starting off this tutorial and some things in the VCM scanner that I've set up already and I've tested to make sure that they're ready to go and we can reference them as we're calibrating and we're tuning. And if you want to go in and set these up on your vehicle in terms of some of the scanner settings and some of the things I'm going to be working with in logging, you're able to do that. Let's jump in here and let's take a look at our calibration file of where we're at in terms of our prep for our file. Now, when we're dialing in our mass airflow curve, we're essentially trying to validate our fuel and airflow model. We're not concerned about dialing in our spark timing. In fact, we've ran really low spark timings. Let's go and reference that very first thing here because we've prepped that in our base map creation, and I just talked about things briefly as we were setting things up manually by hand. Let's go here to our engine, move from general, and we're going to go over here into spark. And if we jump here under advanced, we're going to jump now down here into borderline, into the borderline knock table. So we have our maximum brake torque and we have our borderline. We always want to find the maximum brake torque is higher than the borderline, so we're sourcing our spark timing values from a singular table and it's not bouncing between the maximum brake torque and the borderline. Now, in this situation, we've rescaled our load axes to all of our tables here and referencing our spark timing. We've scaled them up to 2.0 load. Now, the engine control module technically can calculate higher than 2.0 load, and we're going to be exceeding 2.0 load, but when we're looking at our VCM scanner in terms of our logging, we're not going to be able to log past 2.0 load. There's going to be a cap there. So I didn't bother scaling my load axes out here higher than 2.0 load. Now, what's to note about this is I purposely went in and scaled down the spark timing very, very low and being extra conservative so that we can start to calibrate our airflow model, meaning our mass airflow curve or our fuel model, our injector data, to be able to get the results that we need so that we hit the desired target EQ ratio or lambda as we're calibrating and tuning everything. We want to make sure that the spark timing is not playing a role, not going to create any kind of knock or pre-ignition, damage the engine as we're doing our airflow tuning, or again, our fuel model tuning. So I went in and I set the spark timing values relatively low at this last load axis at 2.0 load. And even at 1.7 load, I've also scaled these down. Now, when we're taking a look at this, we have to consider in terms of the spark timing we're commanding, what type of fuel we're running, what kind of boost we're going to be running, also what kind of engine compression ratio we have. This engine is a high compression engine. It's a built bottom end. In fact, the whole engine's built. It's 11:1 static compression on this engine. So it's high compression, and we're running a VMP supercharger that has a larger than stock pulley ratio. We have a lot more boost we're going to be running. We should be running roughly 20 to 22 pounds. We'll have to see how that pans out as we're doing our pulls. And we're running ethanol fuel. So with the ethanol fuel, we have a higher knock tolerance. We can run a lot more spark timing before we run into pre-ignition or knock conditions. So in that sense, we can raise our spark timing, but we're running a lot more airflow and boost into the engine. Our cylinder pressure is going to increase and our static compression ratio is also much higher. So our cylinder pressure is going to be substantially higher than it would be in a stock condition. Now, the ethanol fuel will help offset that, but we want to be conservative with way we're approaching this. So I'm going to run my timing here at 7-8 degrees in this last load column here, and that should allow me to do the pulls without having to worry about any kind of engine damage that might occur if I'm slightly lean in my mixture as I'm starting to initiate a pull. Okay, so that's one aspect here. Another aspect, if taking a look here under airflow, under our general tab here, we find our airflow versus voltage. We're going to be dialing this MAF curve in and validating this, making sure the airflow modeling is good. But we wanted to turn off our speed density influencing. So I've went in and I turned off the MAF adaptation, and I've also turned off the cylinder air anticipation. That's going to allow me to ignore the speed density right now and be on a pure MAF-based style tuning. We want to validate the MAF curve, then we can turn on our speed density, and then we can see the influencing on our fuel and airflow model and see if we have to adjust anything from that point. But right now we have focused ourselves here on essentially pure math mode. Now another thing I want to talk about here real quick, if you have a 3-valve, a mod motor, comparing it to a GT500, one of the differences here in looking at the calibration, we don't have a load with math failed table that we have to calibrate for a GT500. That's something you would have to do on a 3-valve. So after you've dialed in your math curve, after you've dialed your speed density in, after you have a solid load calculation, you would have to go repopulate that load with math failed table to put the proper load indexing in that table based on the recalibration of your airflow models. So that's another step you'd have to take. We don't have to do that here with the GT500, but I wanted to mention that because that is important. So taking a look at this, that should be all we really need to note. In here, we are not going to be touching our speed density tables at all. We're going to leave these alone, and if we need to adjust them, we will. Ford has done an excellent job on the GT500s for populating the table to see boost. We're going to be checking our actual map pressure reading from a map pressure sensor. I have a CTSV 3-bar map sensor, factory GM map sensor. I have it fitted on the engine right now, and I've wired it into the MPVI2 ProLink cable. So I have that coming in on my analog 2 input. We can log that, we can compare it against the calculated map pressure, and we can find if there's an error there. We can adjust our speed density tables. We'll find that we may not need to. Ford, again, has done an excellent job, and a lot of times if I'm calibrating and tuning a GT500, I don't even touch the speed density tables because they're pretty good already, and they require very little work. So I wanted to mention that. This video, again, is just going to be focusing on this mass airflow calibration process. So that should be probably the extent of what we need to talk about in the calibration. Now there is something under general here that I do want to go in and change. The watt multiplier, I'm going to set this at 1.99 and the max multiplier both at 1.99.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.